Hey guys, welcome back to attempt number 2 of making this video. I made a small mistake and it really bugged me. And because I know some of you guys get really annoyed when I make a mistake, so we're gonna go over it again. We're doing section 5.3, part 2, solving exponential functions. Oh, you can see me this time. Let me turn off my camera. You know what? You guys already saw me do it. You're gonna see me in the video, and we're gonna do some math. All right. Before we begin, we need to go over some laws of exponents. Laws of exponents, right? We got to go over these laws, and then I'll go over the top one. All right. Law number 1, if you have a to the power of s times a to the power of t, that means you're going to get a to the power of s plus t. What does that mean, mister? That means if I have 3 to the power of 2 times 3 to the power of 3, that's going to equal 3 to the power of 5. Law number 2, if you have 1 to the power of anything, that's always equal to 1. 1 to any power is still the same. Law number 3, if you have a to the power of s to the power of t, that becomes a to the power of ast. What does that mean? That means if you have 3 to the power of 2 to the power of 3, that's going to be 3 to the power of 6 because you multiply. Rule number 4, if you have a to the negative s, so if you have a negative exponent, that's going to be 1 over a to the power of s. Okay, which also looks like 1 over a to the s. What does that mean, mister? So that means that we have 5 to the negative 2, that's going to look like 1 over 5 to the power of 2, which is the same thing as 1 over 5 squared. Okay, last but not least, we have 2 more. We have number 4. We already did number 4. We have number 5. Number 5 says, if you have 2 things being raised to a power, they both get the power. Right, so if you have 5x to the power of 2, that means you get 5 squared x squared. And then the last one is our favorite one. It's a friend. Anything to the power of 0 is 1. Doesn't matter what number it is, it's always 1. Okay, make sure you write these down. They're really good to remember because they're very important. And I say that as I erase it. So go back and rewind if you have to. All right, next is we have this very special rule right here. And it just uses common sense. If we have something of the same base equal to some raised to a power, so we have a to the power u equal to a to the power v, that means u has to be v. That's the only way that's possible. There is no other way. All right, we're not trying to trick you. It makes sense. All right, and right here you have this very nice example. 4 to the 2x minus 1 equals a to the x. All right, we're gonna start with this one, and this is where it gets hard. You know, we're gonna have some easier examples last. I don't know why I chose this one first, but it is what it is. So this looks hard, but you got to remember 4 is equal to 2 to the power of 2, and 8 is equal to 2 to the power of 3. We're going to use this information to help us get the right answer. So that means we're going to rewrite as 4 as 2, and 4 is being raised to the 2x minus 1, and 8 we're going to write as 2 to the power of 3, and that's being raised to the power of x. Because of our exponent rules, we have power to a power, so we have to multiply this. So you're going to get 2 to the power of 4x minus 2 equal to 2 to the power of 3x because we multiply, right? Now that the bases are the same, we're going to let 4x minus 2 equal to 3x. Why? Because they are the same thing, right? We have to find out what they're equal to. So we're going to do minus 3x here, minus 3x here, plus 2 here, plus 2 here. This goes away, this goes away. You're going to get x is equal to 2. And that's our answer. All right, and if you want to make sure that it works, just plug it in. You're going to get 2, this is going to become 8 minus 2. That's 2 to the power of 6. And this also becomes 2 to the power of 6. So it checks out, okay? Let's go over another example. And here is an elegant way of writing it with other reasons, okay? All right, let's go over another example. Oh, we have our favorite number e. This one looks a little bit more complicated. It really isn't. The first things first, you see all of this, you're like, ew, mister, I don't like it. It looks fugly. You're going to be like, okay, no, it's not. It's just math. Don't be scared. My screen's a little bit delayed. I don't know what's going on here. Let's see, guys. Let's see. I'm going to stop mirroring, and then I'm going to mirror. And this is gonna stay in the video because I am not gonna rewrite this video a third time. All right, so we're gonna do this part, okay? We're gonna rewrite this, all right? We're gonna keep e to the negative x squared the same. Where this is power to a power, so we're gonna rewrite that as multiplication, so e to the 2x. And then because this is negative, we're gonna rewrite that as e to the negative 3, okay? And then now they have the same base and they're being multiplied, so we're gonna change this into addition. So 2x plus negative 3 is 2x minus 3. And this left side stays like this. You know, negative x squared equals 2x minus 3. Now, since the bases are the same, we can solve for the top part, just the exponent. So we're gonna have negative x squared equal to 2x minus 3. What all that means, we got to solve for this. You're not gonna know what to do, but I'm gonna show you what we do. We do plus x squared to both sides of the equal sign. You're gonna get 0 is equal to x squared plus 2x minus 3. Right? This is an easy factor. All right, we should know how to do this by now. That's gonna be x plus 3 times x minus 1 equal to 0, right? That means x is gonna equal to negative 3 and positive 1. So that's our solution set. And bam, we're done. But wait, there's more. I have some more examples that are a little bit easier. All right. We have 7 to the power of x equals 7 to the power of 3. The bases are the same, so that's just x equals to 3. All right. This next one looks a little confusing, but you got to know that 16 is 2 to the power of 4. Okay. So you're gonna have 2 to the negative x equal to 2 to the power of 4. Same base, so now we can rewrite it as negative x equal to 4. What does that mean? X is equal to negative 4. Bam, roasted. All right, we can rewrite this one as 1 over 5 squared. 1 over 5 to the power of 2 equal to 1 over 5 to the power of x. That means x is equal to 2. Boom, done. All right, that's just somewhat easy problems. All right, next one. We're just gonna do 71. We're not gonna do 73 because that's just more quadratic stuff, and we know how to do quadratics. All right, 3 to the x cubed times 9x, right? So 9x is actually 3 to the power of 2 power of x. We're gonna take our time here, right? We have this. That means we're gonna get 3 to the x cubed equal to 3 to the 2x. All right. Now that our bases are the same, we're going to set the exponents equal to each other. We're gonna have x cubed equal to 2x. Some of you guys are gonna want to divide by 2. No, that's wrong. Stop doing that. Slap your hand. Just go like, don't do that. All right. What you're gonna do is you're gonna get the x's on the same side. You're gonna do that by doing minus 2x minus 2x. Okay. The right side becomes 0, and the left side is equal to x cubed minus 2x equal to 0. Okay. Now that the x's are on the same side, you're just gonna factor this. You're gonna get an x on this side, and then you're gonna be left with x squared minus 2 equal to 0. That means that x is equal to 0, but we're also gonna get x is equal to plus or minus square root of 2. Mister, how did you get that? So if you get x squared minus 2 equal to 0, you're gonna do plus 2 to both sides. That goes away. You're gonna get x squared equals to 2. Square root of both sides, you're gonna get x is equal to plus or minus 2. Square root of 2. All right. And that's basically it, guys. If you have questions, ask me in class. All right. And if you're on YouTube, just leave a comment and maybe I'll respond. Bye, guys.